Hello Internet, my name is Quinn and this is Blondihacks. So today we're going to look at common machining mistakes and how to prevent them. If you like this content, please consider supporting me on Patreon, and there's a link down there in the description. Okay, let's dive in. So let's say I set out to make one of these guys, and of course you'll recognize this as the valve stem from a magnetic flux pump. And I'm sure I don't have to tell you, the critical dimension on these guys is the diameter of the jack pin. So let's go over to the lathe to see how this is made. Okay, so we turn this down to close to our diameter, and then we just take a measurement here. This is going to be our last pass, and we need to know how far we have to go. And it looks like we are at 464, and the diameter needs to be 450 for a standard flux pump jack pin. So we go down to the cross slide and we dial in 10, 12, 14, perfect. And we do our final pass. It's looking good. Confidence is high. We take our final measurement, confident we've got it, and oh no, we are 1.5 thou under. And standard imperial fist shake. By the way, if you need a metric fist shake, there's a table to convert that on page 762 of Machinery's Handbook. So what went wrong here? Do you see it? Do you see it? What's that? That is a chip on the anvil of our micrometer. This is an example of a very common reason why you're going to end up overshooting your dimensions and often ruining the part. If you don't have your anvils and your parts clean, if there's a little chip in there, what's happening then is the micrometer is reading a dimension larger than the part actually is, which then causes you to take a deeper cut on your final pass than you actually should have. And that's why you got to keep everything clean. So the most common cause of overshooting dimensions on the lathe is inflated measurements. And on the micrometer, that can be caused by, as we've seen here, chips caught under them, the material not being clean, but it can also be caused by incorrect use of your measuring tools. Now, of course, fundamentally, a micrometer is just a very precise screw. You turn the screw, and the anvil moves down, and you take your measurement. However, like any screw, you can tighten it to different amounts of torque. If you've ever worked on cars, for example, you know that all of the really important bolts like cylinder heads and wheel lugs, that sort of thing, they all have a torque rating. And what that actually is a proxy for measuring the stretch on those bolts. Bolts are designed to stretch a little bit so that they will act like a little spring and hold things tightly together. You don't want to do that with your micrometer. What you're trying to do is get that thread to be just tight enough that you've got the measurement without going too tight. So how do we do that? Well, like a lot of things in machining, it really comes down to feel. As you gain experience, you'll develop the right feel. There's a certain tension where you feel the anvil touching down, but you're not like compressing it. You're not tightening the bolt against the surface. You're just kind of touching it to where you can feel a little resistance when you wiggle it. You'll often see machinists kind of wiggling measuring tools, and that's why, so you can kind of get that feel. Luckily for beginners, there's an easier option. Like a lot of things in machining, there are overlapping skills that you kind of have to acquire all at once to get good at everything. So the more you can isolate those skills from each other, I think the faster you will learn. So rather than trying to learn how to hit dimensions on the lathe while also trying to learn the perfect feel of a micrometer, we can eliminate the micrometer variable from your learning curve by buying this type of micrometer, which has this little thumb knob on the end. And what this is a little ratchet, and it works like the torque wrench that you might use on a car, where it's set to release at just the right amount of torque. So when these anvils are squeezing the perfect amount on the material, this little ratchet will click. So you can still use your barrel for big moves, but then once you get close to your work, you want to make sure your anvils are squared up, and then just switch to using this thumb wheel, and when the tension is just right, you'll hear it click. And then as a beginner, I also recommend just setting this little lock here. That'll make sure that you don't disturb anything as you remove the micrometer from the work, and then that will give you an accurate measurement every time. Another good trick when you're learning is do these measurements multiple times because there's lots of little mistakes that you can make while taking a measurement. You know, you might measure out here where there's a little bit of a burr on the part, or you might measure too far in where there's a little bit of a fillet in there. You might not have your anvils fully squared up. So there's lots of little mistakes you can make. So if the measurement is really important, or when you're learning, do every measurement 3 times and just compare the results, and that'll help you know that you're getting it correct. If you measure something multiple times and you get the same number, you know, most of those times, that's probably your measurement. Now, when you just need a quick measurement, such as on your roughing passes, and precision is a little less important, you're probably going to use your calipers. Now, these guys have all sorts of new types of errors that you can make with them. First and foremost, it's important to note that these jaws are long and skinny, and there's a lot of leverage on the rack here that moves the needle. So what's important about that is that there is quite a bit of flex in this whole system. So when you clamp down on something, it's very easy to get that tension a little too high or a little too low, and you can see that I can get 2 or 3 thousandths of variation just by applying different amounts of pressure. So you really got to watch for that with these guys. They have a lot of flex in them. And of course, just like a micrometer, they are susceptible to having chips in the jaws, so make sure everything is clean before you take a measurement. And these guys have a thin area near the ends of the jaws, and the jaws themselves are also overall thinner than a micrometer, which is very useful for getting into tight spaces, but it can also get you into trouble, because that means it's quite a bit easier than a micrometer to get the jaws crooked, and you can't always feel, you know, when you're crooked. And as you can see on the dial there, you know, getting that angle wrong again accounts for a couple thousandths of variation in your reading. So got to make sure that those jaws are seated on there right, and your tension is just right on the jaws to get an accurate measurement. And once again, if you're unsure, just take the measurement, you know, a few times, and you'll get a sense of when it's right. The other thing to watch for with these guys is that they are properly zeroed, and it's very easy to get a chip on the jaws and mess up your zero, especially with the digital ones, because you're re-zeroing them all the time to do arithmetic and such. So when this guy's all the way down, oh, look at that. I've got a 1 thou reading there even though my jaws are closed. So if I zero this right now, I might actually be messing up the reading on it. Whereas if I just clean those jaws out, there's my zero right there. So be careful when you zero these guys. Make sure the jaws are clean and you're not introducing error by zeroing it in the wrong place. Another big source of error that for some of us never goes away is math. As you're doing your turning passes, you're doing a lot of arithmetic to keep track of where you are and how far you need to go, and it's very easy to make mistakes. You know, if you're trying to subtract 117 from 251, and you know you're doing that over and over all day, sooner or later you're going to make a mistake in that arithmetic. So some things you can do to help minimize that: double check, you know, all of your measurements. Try to work in whole numbers. You know, because micrometers, for example, are marked in 25 thou increments for imperial measurements. Try to keep your passes in those increments so that it's easier to do the arithmetic in your head. The easier you make the math on yourself, the less likely you are to make mistakes. So don't feel bad if you can't factor prime numbers in your head. Just work with the limits of the human brain. And similarly, when you're designing your parts, try to keep the dimensions, you know, pleasant to work with. Don't make your holes 167 thou. You know, make it 150, make it 175. You know, make them pleasant numbers to again reduce errors when it comes time to try and hit those dimensions. And if you do, you will occasionally have to, you know, work with some 17s and some 13s, but just try to double check those measurements. You know, learn when you're in an area where you're likely to make a mistake and double check your work. Now let's say we set out to make this guy, which of course is a standard pneumatic slide plate for a hydraulic crankcase. And as I'm sure you know, the critical dimension on these guys is the distance across the narrow part of the alignment pins. And we need that to be 1 inch 50 thou, plus or minus 2. So we're looking good there. And let's check the other side. And uh-oh, what happened there? So let's take a look at how I made this. Did you see it? Did you see where I made that mistake? Let's jump in the DeLorean and go take another look. Well, there's my huckleberry right there. That center punch is a little bit off, and I didn't catch it until the part was done. So this part is ruined. So what have we learned here? Allow me to explain this takeaway via racing metaphor, because racing is a metaphor for all things in life. In racing, we say that if you went off the track in turn 6, your mistake was actually in turn 3. If you start to get a little bit off the driving line, if you don't notice it, then as you progress through the subsequent corners, you get further and further off that line until the point where you actually realize you're off the line and it's too late and you attempt to correct and the mistake is too big and you're in the dirt and your coach is yelling at you. The same applies to machining. The earlier in the process you can catch mistakes, the less damage they'll do to you. So this mistake could have been as early as the drawing. I have made plenty of mistakes in my drawing that I didn't discover until the part was finished. So make sure you're being as meticulous as you can in the earlier phases of the production of your part, because mistakes made early on will magnify the further into the process you get from drawing to finished part. So in this specific case, the mistake I made was being too quick with the center punch. There's a technique whereby you can feel the crossing point of the layout lines, even though it's just markings in that fluid, you can actually feel them with the center punch. And if you're very careful, you can feel the exact center of where those lines cross. So make sure you're lined up there and then hit that center punch carefully once you're on it. And something that I think a lot of newcomers don't realize is that you can actually move center punches. So if you hit that punch and it's off a little bit, hit that punch again at a little bit of an angle and you can actually move it a little bit in any direction. So do that until your punch is actually on those layout marks before you go and you center drill and make that mistake much, much worse. Perfect. But hey, cards on the table. Sometimes you're not going to be able to prevent mistakes, but you still need these parts, and you've put a ton of work into them. What can you do? I mean, look at me. My flux pump and my hydraulic crankcase are down. How am I going to get to space now? The question is, who do I know that's really good at fixing stuff? Hey, Tony, fix these for me, would you?